No, so the example here is just kind of like what I've been talking about. Okay, so in 10th grade there are 280 students, a total of 200 students in geometry, 66 in algebra 2, and 45 in both. 31 take algebra 2 trig only. Draw a Venn diagram that shows all that. Okay. I like to kind of show this on the outside. S equals 280. There's 280 kids in this whole big group. We have, the only things we have to worry about showing are geometry and algebra 2. I think, it's like I'm looking at this problem. It says algebra 2 here, it says algebra 2 trig here. Is that the same thing? None of the math courses taken above. Algebra 2, no, they're different. There's algebra 2 and there's algebra 2. Okay, so we have 3 zones to think about. We have, I'm going to redo this in a second, but in general, when you're drawing 3 sets in a Venn diagram, you kind of have to show that, show all the different overlaps between the 2 different things. If this is geometry and this is algebra 2 and this is algebra 2 trig, we have to think about, gosh, someone could take, in this zone right here, it would be in geometry and algebra 2, but not also in algebra 2 trig. So yeah, I'm going to put the numbers in here, and then I'm going to redraw this. So don't draw anything yet. This is just for workspace for in general, but I'm going to redraw it with separate circles in a minute, and you'll see why. All right, so there's 280 in the whole thing. There's 200 in geometry. Now, where do I put that 200? Well, it's kind of hard to say right now because I don't know of those. There's 200 in this circle, but there's kind of 4 areas in this circle, so I don't really know at first where to put that. So I'm just going to put an equals 200 on the outside to represent that. I know this circle is going to eventually include 200 in those 4 zones, but I don't know for sure yet how it's split up. Total of 66 are in algebra 2, so this is total 66. And 45 of those are in here. So this little zone here has to have, 31? No, 45, sorry. 31 are just in here and only in here, so that's how that goes. They're not in this part. So what I mean is I want to redraw this with this circle. Can I do this? Will this work? Can I move this? No, I can't. With this circle separated from the other 2, because this is a mess, and it's a mess I don't need to see. So I'm going to redo this. I'm going to do it where I have a geometry circle. I have an algebra 2, that's kind of small. An algebra 2 circle. The size of these don't really matter. And I'm going to have an algebra 2 trig circle that's totally mutually exclusive to those other 2, because that's what I'm led to believe. So I kind of had to do that twice to figure out the best way to do it. Don't let that surprise you if that happens. All right, so there's 280 in the whole sample space. There's 200 in here. So I'm just going to hold that there as a placeholder. There's 31 in here. Like, they were their own thing, right? They don't do anything else. They're just an algebra 2 trig. There's 66 in this total. That's 66. 45 are in here. So now I can start to fill everything else out. There's 45 in there, and there's supposed to be 66 in this whole circle. I know how many are in this moon out here. This is 21, because I have to have that equal 66. So if I just subtract 45 from 66, I figure out how many are left in there. So that's 66. Same thing over here. I know this is supposed to be 200. 45 are already spoken for, so in here there has to be 155. Then, what about this 280? Well, there's 280 total. If I add all this up, this is 221, if I add all that stuff up, I want to figure out how many are in all the classes, then I know that the rest is outside all the classes to make that. In all the classes, if I was going to add everybody up, I should add 21 plus 45, because these sets are actually mutually exclusive. I can add these. All the separate zones in the, all the footballs and moons and stuff, they are actually separate. The circles aren't separate, notice, because there's some intersection. But if I add all those up, I get 221, 252. So out here, floating around, that are not part of this, has to be the rest, which would be 260, 280. That has to be 28 students who are not in any of those classes. So now I kind of have a complete picture. I have where all the students go. This whole 280 is kind of accounted for, and I've accounted for all the intersections and overlaps. Find the probability that a randomly selected 10th grader, okay, randomly selected 10th grader, don't go any farther, I know it's at 280, takes none of the math courses mentioned above. Oh, that's the last thing I just figured out. There's 28 of those 280 who are not in anything. Find the probability that a randomly selected 10th grader. Okay, so out of the 280, takes either geometry or algebra 2. So this would be in this whole, I could highlight it. This would be all of this all together. So everybody in this yellow snowman. I'm going to get rid of that because we might not want that around for long. But yes, it's all these three together. That would be 221. Notice it's 200 plus, I'll write this over here. 200 plus 66 minus 45. Or you could look at it this way, 21 plus 45 plus 155. In my head, I just went 200 because that's a nice number plus this 21 to get 221. Oh, does that reduce? I recognize those from other videos. No, it doesn't. Okay. Fine. And the last one, find the probability that randomly select 10th grader. Okay. Not even reading the rest of it yet. Out of 280. Takes geometry. Given that. Oh, no. The 280 is not right. Given that changes everything, right? Remember that. Given that they already take algebra 2 trig. So out of the algebra 2 trig people, given that they take algebra 2 trig, how many of those also take geometry? Well, it's 0, isn't it? There's nobody that takes both. This would be a more interesting question if it was algebra 2. If they said, find the probability that a randomly selected 10th grader takes geometry, given that they take algebra 2. Oh, can I change that? So let's pretend this is a different question. This is a much more interesting question. Change this to just algebra 2. So now we're in purple mode. In purple mode, given that they take algebra 2, so that's out of those 66, how many of those also take geometry? Well, 45 of them do. So that's this fraction. So different question there at the end. Makes it a little more interesting. Okay. Yay, we get to color. Okay, so shade each of the Venn diagrams below to represent this stuff. So where's the probability of not A? These are great test questions, by the way. So I need to indicate in the picture here all the cases that would be outside of A. Well, it's not in A, it's everything else. So shade around there, but we do shade the entire sample space other than that. So the fact that B is sitting here is kind of like, who cares, right? B has nothing to do with this question. So I shaded around that B circle however I needed to represent not A. So it's everything except what's in the A circle. All right, this means not, and then what it's notting is A and B. All right, so A and B was this. I want everything but that. So that's going to be the little window peeking through on this thing. So not that stuff, but everything else. So here, since A and B are represented in the problem, the A circle kind of means something. There's times when I'm following the A line. There's times when I'm following the B line. But in the end, it's just that. Everything that's outside of the intersection of A and B. This is OR, and we have an A naught intersection with a B naught. So remember, A naught was that. So we're thinking it's going to be like everything outside of A. That's all this stuff. Including that. So all that we're going to intersect with different color. Oh, let's go red, see what this looks like. Everything outside of B is this. And everything outside of that. Including all this. So could you do this in your head? Like, what did we just shade in both colors? What did we shade in red and in yellow? I think the only thing, and I could go backwards a little bit. So there was all the yellow. Sorry, this is all the red. And there's all the yellow. What got shaded twice? Can you remember? Oh, can I bring it back? I can't bring it back. All right, outside of both. So that's one way to do it. I don't know if that was easy to see. I can tell what that was going to be now, but so if you've got that, just bear with me for a second. I'm going to another way to explain this. You could look at the different zones, and really mutually exclusive zones, sort of. There's the outside everything. There's stuff in A. There's stuff in both. There's stuff in B. You could think of these 4 zones and go, okay, which ones of these zones make this true, or kind of satisfy this? And let's do that. So of those 4 zones, I'll go back to yellow here too. Is it what's outside of A, like this zone out here, does that make all of this true? If it's outside of everything, is it outside of A or is it outside of B? Yes, because it's outside of both. If it's in here, is it outside of A intersected with, I guess this is and, isn't it? Yeah, wait, sorry, this is OR. This is OR, this is union. So it's everything outside of A and everything inside of B. Oh, wait a second. No, I did that right. Double second guessing myself on B. Outside of A or outside of B. What about the stuff in here? Is this outside of A or outside of B? Yes, it is, because it's outside of B. The stuff in here, is it outside of A or outside of B? No, it's not. What about this stuff? This is not outside of A or outside of B because it's in both of them. This one, outside of A or outside of B? Yes, because it's outside of A, and we've done everything else. So this is it. You know what, kids? This looks exactly like part B. This is the same. This one took a lot more thinking, though, didn't it? So this is all the stuff that was either highlighted in red or in yellow before. All right, so now they're putting probabilities on this Venn diagram, which is commonly done. Probability of A is 0.04, so this equals 0.0, I'm still in purple. And probability of B, probability of not B is 0.3. You know what that makes me want to do? Just write this as 0.7. Oh, not 0.04. Silly. At least I noticed it early. Go back to writing too. This is 40%, not 4%. The probability of not B is 3. That tells me right away that the probability of B is 0.7. So let's just call that 0.7. Probability of both of them, this is an and, is 0.2. So I know there's a 0.2 that goes in here. Now let's fill out the rest of this. Oh, by the way, I know the whole thing is 100% because this is all in percentages now, or in decimals. So if this is 0.2, then I know this also has to be 0.2 because these have to add to 0.4. These two zones have to add to 0.7. That makes this out here. So the outside, everything, this all adds now to 90%. So there's got to be 10% on the outside. What's the probability of not B? You told me that. It's 0.3. That's a really easy question. Okay. For the probability of A or B. Okay. This probably wasn't the question that was intended. But find the probability of A or B. I might ask a couple more here if I have time because this is really good stuff. A or B. So that's everything in the, basically that's everything in this whole snowman shape. That's all of this. That's 90%. If I count all that as one layer, it's everything but this. A better question would have been something like, well, first of all, find the probability of B. Another one you might get that's kind of interesting, find the probability of, so other questions. Find the probability of not A. Probability of not A is everything outside of A. Well, we knew this was already 0.4, so this should be 0.6. Does that work out? Yeah, because that's the 0.5 plus the 0.1. Okay, great. There's another problem. Probability of A and B not. Ooh, you thought it was going to be easy. A and B, that's 0.2, so not that would be 0.8. You could also think of that as this 0.2 plus this 0.5 plus this 0.1. Just some extra questions here to make you think. Okay, that's enough probability for one day. I'll see you in class.